Hello AAF kids. I am at a horrendous, horrible, awful county meeting just up the road from here, and I really would prefer to be in class teaching you, but sigh, it is not to be. Anyway, you have finished your quiz. Congratulations. Please write down these problems for homework tonight. They are a bunch of word problems, which we will call from now on word problems, just because we're cool like that, modeling problems. The reason they're called modeling problems is because they represent real-world situations where you're going to write a math model. And a math model just means a prediction equation, based on data. And we are going to start small, and with the real-world problems, the data that we're going to be given is only 2 points. And guess what? 2 points determine a line. So we are going to be writing, our model is going to be a linear function. So these notes that I'm going to give you on modeling problems, we are going to do modeling problems in virtually every unit this year, and I'm not going to repeat these notes. So I need to make sure that you have these notes for modeling problems, and that when we are in the quadratic unit or the rational unit or the exponential unit and we start modeling problems, you refer back to these notes, because the majority of these notes go with every modeling problem. So the first thing you have to do when you read a word problem, remember, modeling problem means word problem. In the words, you need to find some things to relate. Since we are in the functions, this is analysis and applications of functions, we only need to find 2 things to relate. We can only deal with an independent and a dependent variable. We are not ready for multivariable. So independent and dependent, generally we choose the independent to be x and the dependent to be y, but we don't have to, right? If our independent variable is time, we might call it t, and if our dependent distance is miles, we might call, dependent variable is distance, we might call it d. You get to choose. So find your independent and dependent quantities and then assign them variables. If you want to just do x and y, that's fine, but you can assign them any variables you want. It's important, though, that in a modeling problem you communicate the variables that you want to use. Since you're going to be finding 2 variables, and since we are in the linear unit, you are going to want to find the info from the words, and the info is related to your variables. So you want to find your x comma y and order them, and then you're going to develop the model. Since we are in the linear unit, we are going to write a linear model, which means I need 1 or more points, and I need a slope, because my model is a linear function in point-slope form. Graph your model. Now on a test, I have to ask you to graph it. On your homework, not every homework problem asks you to graph, but I'm going to suggest that you practice graphing your models. Hint, on most assessments for modeling problems, you're going to be graphing, so you might as well practice. When you've been practicing linear functions, I've always made you label the x and y intercepts, but in addition to the intercepts, you also, if you're going to do a real-world situation, you should plot the given information, the information that you used to generate your model. And then when you name your model, the name of your model is just its equation. It is, before you have, I haven't really emphasized labeling axes, but when you're doing a word problem, please do not label the axes just with X and Y. You need to have units on your axes. In other words, words. In other words, words. Also a scale, and I'll show you what I mean by scale when we do the example. Then you're going to answer questions after you have a model, and you'll notice a certain flow in every unit. The questions are going to give you an independent variable and ask you to generate dependent. This is just plug and chug. You're going to have a calculator for these problems. I don't need to see a lot of math. I just need to show me that you plug in and show me the answer with units. However, if I'm giving you a dependent and you generate an independent, this requires algebra to solve for X. It's an algebra test. You're going to get points for algebra. So many times I take a point off here because a student just gives me an answer without showing me that where they've plugged in the value. I don't need to see computations, but I have to show you plugged in. Also, so many times I don't care if you answer in full sentences, but answer the problem in words and make sure you include units. So I like to remind kids, always label your axes. Womp womp. Alright, so you had these notes, so hopefully this handout that the sub gave you, so hopefully you have taken these notes, and now with the handout that the substitute has given you, this is our first problem. So notice I've bolded some things here. The number of dollars per month it costs to own a car is a function of the number of kilometers. So is my equal sign. So the number of dollars it costs to own a car is a function of the number of kilometers. So the number of dollars is a function of the number of kilometers. So I say to myself, I'm dealing with kilometers. I choose to call that X. And I'm dealing with dollars. I choose to call that Y. So is it true? Check. Is it true that the number of kilometers I drive my car is it true that the number of dollars I spend on my car is dependent upon the number of kilometers I drive? If the cost varies linearly, that's my model. With distance, again, Y is X. Now look at your notes. The next thing I have to do after I assign variables and units is pull out the information from so the information I have is $366, that's a Y, per month for kilometers, that's an X. So 300 goes with 366, and $510 is a Y per month for 1,500 kilometers. Define variables, check, and write the particular equation. That's my model. using my data, expressing the cost in terms of distance. So y stuff is equal to x stuff. So here are my x, y, x, y. My model, I've been told, is a line. I have 2 points, so I'm going to use point slope y minus blank equals blank parentheses x minus blank. Oops, they want the cost in terms of distance. That means they want y by itself. So I'm going to write y is equal to blank parentheses x minus blank, and then move this y coordinate over here. So I will put one of these points, I don't care which, I choose this one. So I'll put the y here, and I'll put the x here, and then I need the slope here. How do I find the slope of any line? The slope of any line is the vertical change compared to the horizontal change. So what do I have? 510 minus 366 over 510 minus 366 over 1500 minus 300. Don't forget units. The y units are dollars and the x units are kilometers. So what is this? This is, and again, you will have a calculator on problems like this. So this is 500 minus, so this is 134 over 1200, which is approximately 0.11 over 1 if you want, dollars per kilometer. Right? My slope has minutes. I'm sorry, has units. 11 cents every kilometer. So this is my model. Okay, this is my model. So, taking my model and graphing it. Oops, I didn't round this property, I think. Let me write this up here. Now let's get a, sorry. Trying to get to my, when I label my axes, do not just write an X, write X in kilometers. And don't just write Y, write Y in dollars. the name of my model is y is equal to 0.11 x minus 300 plus 366. So how do I graph that? I only use the first quadrant because it is not reasonable. Remember our reasonable graph assignment? It is not reasonable to have negative dollars or negative kilometers in this situation. So I am going to plot my 2 points. So remember the 2 points from the problem were 300, 366, and 1500, 510. So let's plot those points. So this scale, right? I need to go from 300 to 1500. So let's pretend that this is, so let's say this is about 300 here. So 300, 600, 9, 12, and 15. And then here I'm going to go, let's say this is 300 and what, 500, 700, 900, and I'm going to plot the point 300, 366, and I'm going to plot the point 1500, 510. Now it's a little difficult to do on this, to do a straight line with this. So I'm just going to do this for right now, but I do want to, so I've completed everything they want. I defined the variables, I wrote the particular equation. This didn't ask me to graph, but remember I told you to graph and label. But graphing and labeling, for a real-world problem, I've graphed the points from the equation, and now I need to ask myself, do the intercepts, or are the intercepts reasonable? Are they reasonable? Well, let's talk about the y-intercept. So the y-intercept means make x 0. So to make x 0, when I make x 0, I go to the equation and I say y is equal to 0.11 negative 300 plus 366. And I go to my calculator and I say to myself, what is 0.11 times and then add 366, and I get 333. I can tell I want to graph it in the reasonable domain, but I want to indicate I understand this linear function has an infinite domain, so I'm going to dash the unreasonable. I graphed in a reasonable domain a solid line, and then I dashed the unreasonable part, because I don't want to. This linear function has an infinite domain and range, so I graphed the infinite domain and range, but I indicated which part was reasonable. My line is so ugly. So if you look at the notes that we took, right? I told you, I took you through the writing the model, defining your variables, deciding who's independent, dependent, getting the points from the equation, using, math and finding the point slope form of a line, graphing it. And labeling the reasonable domain. Then I said you're going to have to answer questions. So your next handout, now notice for this one here, I rounded when I typed this up, I rounded to 0.12, 0.11, 0.12, who really cares? And also when I was asked to express cost in terms of distance, that means write y by itself. It doesn't mean mx plus b, it just means y by itself. So it asks, what is the real world meaning of the y-intercept? That just means interpret the y-intercept. So the y-intercept, remember, we found was 0, 333. What does that mean? I know you can find it, but remember, x was kilometers and y was dollars. So what does that mean? I'm going to write something that will lose you points on an assessment. If you write, I drive 0 kilometers and spend $330, that loses you credit. Okay, that is a literal interpretation. I need you to think. What does this mean? Right? We're talking about the cost of a car. Why would I drive nowhere and still have to pay some money for my car? Well, there are lots of reasons. All you have to think about is one. So here are some examples. You could say things like this. You could say things like, maybe $330 was the cost of the car. I mean, who knows? Maybe you got a clunker from your grandfather, right? And he only charged you $333. Maybe, what else could it be? Maybe $330 is the insurance. Maybe the $333 is the cost of the gas you have to pay per month. Whatever. As long as you are, anything you say, as long as it is reasonable, you're going to get credit. It is not reasonable to say, I have to spend $333 when I drive 0 kilometers. No. Give me a reasonable explanation. Think startup cost. Right? Or think initial cost. Something like that. Alright, the next common problem is to ask about the real world meaning of the slope. What they're actually asking you here for is to use units and to use the word per. Remember, the slope I wrote before is the change in the vertical compared to the change in horizontal. But if you put units on this, this is dollars over kilometers, and you say it is the cost per kilometer. This is what gets you credit for the real world meaning of the slope. Now notice the next two questions say use your model. Use your model to predict, because it is just a model. You only have 2 pieces of data. Anytime you use your model, you are only predicting. How much would it cost? Question. Cost. Is that an X or a Y? Answer. That's a Y. That's why I want you to define variables from the beginning. How much would it cost to drive kilometers, which is a distance? So they, given an X, find a Y. So if they gave me an X, and this is my use my model. So my model is Y is equal to 0.11 or 0.12. I'm just going to write 0.11 because that's what I had in the front. That's what I graphed on the previous slide. X minus 300 plus 366. Oops! Don't write X, silly. Write what? 500. So put 500 here. 500 minus 300 is usually 200. 200 times 0.11 is 22, and 22 plus 366 is 388. Does that make sense? Units. Does that make sense? Let's go back. Right? Does it make sense that at 500 that the cost would be higher than 366? Is it reasonable that there would be a point on my model that is 500, 3, and no, you don't have to put these new ones on there. I'm just asking you a visual. Is this reasonable? Yes, it is reasonable. So you say, this is, if I don't see you plugging in, here's another shortcut way you can do this. Y of 500 equals 388 kilometers. Use your mod. Now let's move on. Use your model. Y equals 0.11 X minus 300 plus 366 to predict how far you would drive. How far you would drive, that's kilometers, which is an X, if you spent $570. That's a Y in dollars. So I need to go to my model and plug in 570 right, for Y. So show me that you plug in. Now do some algebra. You're going to take 570, you're going to subtract 366, you're going to divide by 0.11, and then you're going to add 300. That's going to be the X you find. So on your calculator, $500 minus 366 divided by 0.11 is equal to X. So plug that into your calculator and notice, and remember, you're going to, whatever answer you get, you're going to put kilometers on that. Now before I write down anything, let's go to the graph. So I asked about 570. So 570 is probably here-ish. 570. So 570 will hit my model somewhere over here. So you should expect an X higher than 1500, right? What did you get? 570 minus 366 divided by 0.11 plus 300. Did you get 2,154.5-ish? Okay. Round to one or two places. Don't round to a whole number. Just give me one or two places past the decimal. And then again, think to yourself, is that reasonable? And we looked back at the graph and we said, yeah, we thought that was pretty reasonable. So your homework tonight, going back to the beginning, was again these problems in your book. These are all word problems that you need to follow my directions on, getting the points, write the equation in point slope form, answer questions. Practice showing that you plug in for each variable, appropriate variable, and verifying whether your answer is reasonable. Don't forget that whenever they ask you about the slope, talk about the units and use the word per to indicate the fraction bar. Alright. Know that, again, I am miserable being in a meeting instead of teaching, but I hope that you enjoy and are nice to the substitute, my not being there. And I will see you tomorrow, and please make sure you have these homework problems attempted. Now I want you to look and notice that 1, 3, 7, and 17 are all odd problems. Check the answers in the back of the book. 10 and 14 are even. The answers aren't in the back of the book. Right, so we will check those tomorrow and check those solutions in class tomorrow. Alright, have a great afternoon. Talk to you later, kids.